problem number 38. Has to do with economic order quantity. This is actually a topic that is taught in supply chain, but you can apply it to cash. You can apply it to supply chain when you're having to determine how many units to make. You, as a student, actually do economic order quantity. The concept is when you go to, say, the store to buy groceries, you have a good idea of your usage rate. You also have a good idea of how frequently you go to the store. So then you would be able to determine, you do this in your head, I need to buy so much milk. I need to buy so many cans of mushroom soup, so many bananas, whatever you're purchasing. But there's a blend or there's a trade-off. Even products that are not perishable or they don't obviously go bad or spoil quickly. There's only a certain amount that you want to buy. Now, every time you go to the store, it costs you money. But then you also have the storage costs. So you don't typically go out and buy all your soup for the year or spices for the year. You will buy them as you need them, but you'll buy certain quantities. You don't go and buy perhaps one package of seasoning. You will buy several packages, so you won't have to keep going back to buy it. But you don't go and buy 10 years worth. So there is the trade-off between what is called ordering costs. Those are the costs of driving to the store, wandering around the store, getting your product, versus the cost of, it's either called carrying costs or holding costs to store it. When you have product in your home, you need to have shelving. You need to have a refrigerator to keep your milk cool and cheese and things along that line. You may have a deep freeze for storing or having frozen goods. So there is a trade-off between how frequently you go to the store, which is the ordering costs, and how much product you have in your home or how much inventory you have in your home. So this economic order quantity finds the optimal point. So it tells you every time you go shopping or every time a company makes a number of units, this is how much they should make. It's very much formula based. So just be careful with the calculations. You simply plug the numbers in. So S stands for annual sales. O stands for ordering cost per order. And C is carrying cost per unit. So this is not really an analysis part of the course. This is simply plug those numbers in the formula, calculate. So in this particular case, what you can see is in problem number 38, it asks us to calculate EOQ. So you take the variables, and that's a 2, not a Z or something like that. It is just the number 2, and it is a constant. You take it times the annual number of units of 75,000. You have a cost per order, or every time you place an order, costs you $8, and each unit costs $1.20 to store. So when you do the calculations, you can see that it's 1,000 units. So I place an order of 1,000 units, and then the next time I need to place an order, I place another order of 1,000 units. What that will do is that will minimize your total costs. As you go through the process of ordering, the larger the quantity, let's say you went grocery shopping once a year, you would have minimal ordering costs, but you'd have maximum carrying costs. So they move in opposite directions. Just like if you went grocery shopping every morning, you'd have basically no inventory at the end of the day if you just bought enough food for the day, but you'd be going to the grocery store and you'd be driving there and wearing out your vehicle or paying for public transit. So they go in opposite directions. Where the two intersect, where the two costs intersect, the ordering costs and the carrying costs intersect, is the optimal point. That point is every time I go to buy these units or make these units, I would have 1,000 units. Now, in part B, you need 75,000 units in a year. Every time you place an order, it's 1,000 units. So you simply divide S by EOQ, which is often also just placed as Q or identified as Q. So you're going to make 75 orders a year. To find the average inventory in Part C, it's simply EOQ divided by 2. Because you start off with 1,000 units, you wind up with 0 units. And so the average of that is 500 units. In Part D of question number 38, in this particular case, the first line that they have is actually your ordering costs. You're going to place 75 orders a year, so the number you got from Part B. Each time you place an order is going to be $8. You have a total of $600 of ordering costs. You take the average inventory, the number you calculated in Part C, you multiply it by the carrying cost per unit per year of $1.20, and you also wind up with $600. I mentioned a moment ago that the two cost curves intersect. And of course, we know that when two lines intersect, the X and the Y variables are the same. So in other words, the quantity and the cost are the same. When two cost lines intersect, it means the two cost numbers are the same. So one of the ways to test yourself if you got it right for calculating EOQ is, are my two costs the same? Now, they might be out by a couple pennies just due to rounding, but if you use enough decimal places, they'll be exactly the same. So if you come to the end of the problem and you've got one that's $712 and the other one's $488, you did a calculation error. Where is that calculation error? The calculation error is in Part A. You forgot to take the square root of the number, or you simply multiplied wrong or did some sort of calculation. So if the two numbers, the total ordering costs and the total carrying costs, are not the same, like I said, you could be out by a few pennies, maybe even a couple dollars. You did a calculation error in Part A. And as you can see, if you did a calculation error in Part A, it affects your answers for Part B, Part C, and Part D. So as accounting students, one of the things you like about a balance sheet on a test is my balance sheet balanced. So you're fairly confident that you did well on that question. On an income statement, you have no idea because you don't know what the number is. But if your balance sheet balances, then there's a fairly good chance you got a high mark. Same thing with Part D. If your balance sheet does not balance, you know you're not getting 100%. So Part D is actually very important. If the two costs are the same, you can be fairly assured that you've done the problem correctly. If you haven't got the numbers the same, go back to Part A and recalculate. And that is pretty much guaranteed to be where your error occurs. So I hope that has helped. Take care.